By the end of this lesson, we will be able to interpret a compound inequality. We will first break it apart and then graph their solutions on a number line. For example 1, it asks us to solve and graph the following compound inequality. We have to rewrite the inequality as two separate inequalities for part A, and then for part B we will solve each and graph them. So as you can see, the first thing you should do is rewrite the inequality. Now, I have these images up here because hopefully you remember from class that anytime we have a compound inequality, meaning an inequality with two inequality symbols stated as one sentence, we can separate it. And just like when you separate an Oreo, the middle goes to both pieces. So here we can pretend that the inequality symbols are our cookies and that the middle is this entire piece. Now it's a binomial rather than a single term, just a monomial. In this case, when we break these apart, our left cookie will be attached to the middle, and then our right cookie will also be attached to the middle. So as you can see, this middle piece represents the frosting, goes to both sides with the 13 and the -8. So now we've answered part A. We have it written as two separate inequalities. We should connect them with the word and in this case. -8 is less than or equal to this expression, and this expression has to be less than 13. So our solution for x should be somewhere that makes this expression any number between -8 and 13, only including -8. Let's solve for x like normal. We have to subtract 1 on both sides. We end up with -9 is less than or equal to 3x. We have to divide by 3. I'm dividing by +3, so I do not have to worry about reversing my symbol. And we end up with -3 is less than or equal to x. And we need to get the other set of the solutions. First, we subtract 1. We end up with 3x is less than 12. I now have to divide by 3, and I find that x is less than 4. Now remember, -3 is less than or equal to x really means that x is anything greater than or equal to -3. When it's written backwards, we could read it from the x. X is actually greater than or equal to -3, or some of us prefer to rewrite it. So now our entire solution set consists of this compound statement. -3 has to be smaller than or equal to x, and x has to be smaller than 4. So it must be that x is between 4 and -3. It has to stay less than 4, and then it has to be greater than or equal to -3. So since we're going to read it backwards, I'm going to keep this symbol where it reads -3 is smaller than or equal to all of the answers, which are smaller than 4. Now it's time to graph our solution set. We need to be sure that we include -3 on our number line, as well as +4. So -3, -2, -1. This is 0, 1, 2, 3, 4. Okay, I should have a closed circle on -3 because -3 is included in this solution set. And I should have an open circle on 4. We also need to include all of the values between them. Okay, problem 2. We have to solve and graph this inequality. Let's start out by copying it down. And now for part A, I have to find where the cookies would be, the two inequality symbols, Here's the frosting in the middle. And remember, the frosting, when you pull apart that cookie, goes to both sides. So I should rewrite this as -7 is less than 2x minus 5, but then the middle also reaches to 2x minus 5 is less than or equal to +7. Okay, time to solve. I want to isolate the x by adding 5 to both sides. We have -2 is less than 2x. I now want to divide by 2. I get -1 must be less than x. Now let's solve for x over here. Let's add 5 to both sides. We have 2x is less than or equal to 12. To isolate x, we divide by 2. Division property of equality tells me that x is less than or equal to 6. So while -1 has to be smaller than x, and we have to have x be smaller than or equal to 6, we can rewrite this statement by stating -1 must be smaller than all the answers, which must be smaller than or equal to 6. It's time to graph our solution set. I have to be sure to include -1 and +6. So this is 0, 1, 2, 3, 4, 5, 6. Okay, we need a open circle on -1, but an enclosed or shaded circle on +6. And then of course I need to shade to include all of the real numbers in between. Let's try one more together. First I have to find the two inequality symbols. And if they pretend to be cookies out of an Oreo, the frosting's in between. And again, follow the same rules. The frosting's going to pull apart and attach to both sides. So I have -3 is less than or equal to 3x plus 3. But 3x plus 3 has to be less than or equal to 2x plus 10. Okay, time to solve. This side is still a two-step equation. We subtract 3 from both sides. Same sign, add. I want to isolate x, so I divide by 3 on both sides. I have -2 must be less than or equal to x. Now, here I see x is on both sides when I go to solve, so I have to pick a side for x. I'm going to subtract 2x from both sides, so I end up with 1x plus 3 is less than or equal to 10. We now have to use the subtraction property of equality, and if we find that x must be less than or equal to 7. So our solution set indicates that -2 must be smaller than or equal to x, and at the same time, x must be less than or equal to 7. We can rewrite this solution set as a compound inequality all in one statement. And now it's time to graph. We want to make sure we include -2 all the way to +7 on here. 0, 1, 2, 3, 4, 5, 6, 7. I have a closed circle for both. -2 is included in the solution set, and so is 7. And of course I must shade all of the values in between to make this inequality true. I'd like you to pause the video here, try it on your own, and then press play to check to make sure that you understand how to do it. Okay, the solution set consists of all real numbers between -2 and 5, including -2, but not 5. -2 must be less than or equal to the answers, which are less than 5. Here's the graph. Make sure that you show all of the steps for me to check tomorrow, and we'll practice with some more compound statements. We now know how to interpret an inequality by breaking apart the compound inequalities and then graphing their solutions.